Hello, and thanks for using TickBoom. In this video, I'm continuing on with tackling this question 8B of the 1989 New South Wales 4-unit HSC exam. So this is the second part of a 4-part question. And if you haven't already, I recommend you go and watch the video where I tackled part 1. In that video, I also gave a bit of background as to why this question got its reputation as the hardest question ever on the New South Wales HSC 4-unit curriculum. But for those of you who have watched part 1, you can now stick with me for part 2. So part 2 says to let R be a real number and let M and N be non-zero integers with M not equal to N. And part alpha of this part 2 says to show that if the fractional part of MR is equal to 0, then R is rational. And then part beta says to show that if the fractional part of MR is equal to the fractional part of NR, then R is rational. So a few little proof questions to make up this part 2. So I'll just pick up where I left off in part 1. So for this part 2, we're told that R is a real number and M and N are non-zero integers, and we're also told that M is not equal to N. So they're both not 0 and they're both not equal to each other. And just like before, this part has its own 2 subparts. So part alpha is asking us to show that if the fractional part of M, so the first integer, times the real number R, if that's equal to 0, then R is rational. And I should probably kind of define what a rational number is. So a rational number we can write in the form one integer divided by another. So here I'll write P on Q, where P and Q are both integers. So where P and Q are integers. So essentially what we want to see is, can we write R in this format? Can we write R in the format of one integer divided by another when this condition is true? So kind of going back to something I pointed out in part 1, where I broke up a number into its integer and fractional part, I'll do something similar here. So here we're dealing with MR. So I can say that MR is equal to the integer part of MR plus the fractional part of MR. So again, simple rearranging, let's just say that the fractional part of MR is equal to the actual number, MR, minus the integer part of that number. So from there, I can say if the fractional part of MR is equal to 0, then that must mean MR minus the integer part of MR is equal to 0. So I've just substituted in this result into here. So again, rearranging, we get MR is equal to the integer part of MR. So R is equal to the integer part of MR divided by M. Now the integer part of MR by its definition is an integer, and M we were told is an integer. So R is one integer divided by another integer, which is our definition of rational. So therefore R is rational since the integer part of MR and M are both integers. So yeah, that wasn't too bad at all. I think really, as long as you knew the definition of a rational number, this kind of dropped out really easily. And I think part beta is going to be pretty similar. So if we go part beta, what's that say? That's asking us to show that if the fractional part of MR is equal to the fractional part of NR, then R is rational. So let's see how this one plays out. So if MR is equal to NR, then what we can say using this kind of format, we can say that MR minus the integer part of MR is equal to NR minus the integer part of NR. So I've just done the same thing as I did with MR. I kind of replaced the M with N, but it's the same idea. So now we can just do some rearranging. So I'll bring the NR over, and I'll bring the MR over here. So we'll get MR minus NR is equal to the integer part of MR minus the integer part of NR. So M minus N times R is equal to the integer part of MR minus the integer part of NR. So therefore R can be written as the integer part of MR minus the integer part of NR divided by M minus N. And for the same idea, for the same kind of reasoning, we can say R is rational since one integer minus another integer gives you an integer, and that's what we've got on the top and bottom. So here again, R is written as one integer divided by another. So that's part 2 done. Pretty straightforward actually. I think maybe students who didn't get the marks here, maybe they didn't get them because being the final question on a tough exam, and I guess dealing with these new concepts, maybe some students might get caught up with what type of proof they had to use, and maybe they ended up going down a rabbit hole of something that wasn't fruitful. In the end, we actually didn't need any fancy proof techniques at all. It was just basic algebra. But you could almost imagine a student kind of going to something like induction or contradiction or some other technique, and it kind of not really getting anywhere when all they really had to do was something really straightforward. So I would guess a lot of students probably got the marks on this part, but you can also see how a lot of students might not have got the marks. But there you have it for part 2. Pretty good. So I'd say so far so good on this question as a whole. I mean, part 1 alpha, I think easy marks, just using your calculator. Part beta of part 1, yeah, okay, maybe not as straightforward. But then part 2, pretty good. So I would say so far this question, if this was it, if this question was to stop here, you definitely wouldn't put it in the hardest question ever category. So it must be that as we come to part 3 and part 4, things start to get a bit more interesting. So hopefully so far you found that helpful, and keep your eye out for the next video where I go through part 3, and tick boom.